시면 좋을 것 같아요. 여기 그 소프트웨어 중심 대학 사업단 단장님이신 우리 김영식 교수님 여기 들어와 계셔서 네, 학생들 얼굴도 보고 그러면 좋아하실 것 같아요. 네, 건강하게 잘 돌아왔으니까 네, 보여드리고 네, 지금 말씀드린 것처럼 지금 점심시간이라서 다들 좀 아주 편한 시간은 아니긴 한데 우리가 대면이었으면 우리 막 점심도 먹으면서 같이 발표하고 그럴 텐데 네, 아쉽습니다. 네, 여러분들 네, 무사히 그 2달 동안 미국에서 잘 네, 생활하다가 온 거를 제가 그 코멘트를 봤어요. 네, 평가지를 보고 해서 다들 즐거운 생활을 힘든 상황임에도 불구하고 다들 즐겁게 네, 보내고 온 것 같아요. 즐겁기만 한 것도 아니고 또 프로젝트도 되게 열심히 해서 결과물도 되게 좋은 걸로 알고 있어요. 지금 아마 퍼듀 대학교에 계신 그 지도 교수님께서 퍼블리시하는 그런 부분도 지금 고려하고 계시는 것 같으니까 혹시라도 이제 추가적으로 작업을 해야 되는 부분이 있으면 바쁘더라도 지금 4학년이라서 다들 바쁠 텐데 바쁘더라도 네, 그런 추가 작업 계속 하셔서 좋은 결과물 만들어내면 좋을 것 같아요. 네, 오늘은 그 우리 글로벌 소프트웨어 AI 인재 프로그램에 참여해서 지금 퍼듀 대학교까지 방문하고 퍼듀 대학교에서 프로젝트 진행한 결과를 발표하는 그런 귀국 보고회 형식으로 지금 진행이 될 예정이에요. 그리고 이미 여러분들이 이제 퍼듀 대학교에서 수료를 할 때 발표를 한 번씩 했는데 사실은 그때는 우리 후배들이 많이 이제 참가를 못해서 혹시라도 이제 이번 올해 혹은 내년에 이 글로벌 소프트웨어 이제 프로그램을 참여하고 싶어 하는 이런 학생들이 있으면 아, 나도 여기 한번 선배들이 했던 이런 걸 해보고 싶다 이런 동기를 좀 줄 수 있을 것 같아서 후배들도 많이 초대를 했거든요. 그러니까 여러분 그때 발표했던 거 잘 전달해 주시면 좋겠습니다. 오늘 이제 이거 시작하기 전에 아까 소개드렸던 소프트웨어 중심대학 그 사업 단장님이신 김영식 우리 교수님께 좀 잠깐 인사 말씀을 좀 들었으면 좋겠습니다. 네.
네, 임혜성 교수님 수고 많으시고요. 근데 제가 프로그램을 미리 확인 못했는데 오늘 얼마나 시간이 걸릴까요? 끝나면 얼마나 돼요?
지금 그 한 팀당 저희가 한 10분 정도 소요해서 한 1시간 반 정도 걸릴 것 같습니다. 네.
제가 아마 끝까지 있지는 못할 것 같은데 그렇지 않아도 학생들이 굉장히 많아서 제가 착각했나? 이렇게 갔다 왔던 학생들이 많지 그 생각했었어요. 그리고 또 한 가지는 시차 적응을 했나 생각하다 보니까 시간이 이미 한참 지났더라고요. 시간 가는지를 제가 잘 몰랐고 학생들은 아마 오자마자 수업도 들었고 그렇죠. 또 뭐 임혜성 교수님 말씀처럼 이미 한번 결과 보고를 했지만 또 결과 보고에도 참여했고 뭐 일이 많죠. 그 우여곡절이란 말이 잘 맞는 것 같아요. 지금 마지막 학생 올 때까지 여러 가지 일이 있었고 중간에 일일이 다 점검은 못했어도 아파서 고생, 하여튼 적어도 기록상으로는 실제로 몸이 아팠는지 불편한지 모르겠지만 근데 다행히 또 부모님들이 크게 우려하지 않으신 걸로 들었어요. 그 부분도 참 다행이고 우려하지 않을 만큼 상태가 나빠지지 않았던 것까지 포함해서 그 총장님께서도 계속 관심이 있으셨어요. 그 마지막 학생 왔냐고 내가 헷갈리는데 지난 월요일인지 지지난 월요일인지 한번 말씀 주셨었거든요. 뭐 일일이 다 보고는 못 드렸어도 우리 학생들이 가서 어려운 시기에 가서 좋은 경험하고 온 거에 대해서 다 총장님과도 공유가 됐고 대학 본부에서도 잘 알고 있습니다. 그 전에 아마 내가 그런 얘기 했던 것 같은데 우리 사업단이 전공학생들 물론 연계 전공학생들도 있겠지만 전공학생들에게 기대하는 가장 큰 목표가 성장하는 거예요. 뭐 학교라는 데가 원래 학생들을 키우는 뭐 그런 조직이긴 한데 특히 우리 사업단은 그 정부 예산 받아서 소프트웨어 전문가를 단지 뭐 키우는 데서 그치는 것이 아니고 이 프로그램에 특히 지금 이 글로벌 인턴십이 더 거기에 해당할 것 같고요. 참여했던 학생들이 성장했으면 하는 바람이 있고 아까 이민성 교수 말씀처럼 뭐 성과 발표 이런 걸 통해서는 그게 충분히 확인이 된 것 같아서 굉장히 다행이라고 생각합니다. 한편으로는 뭐 이게 워낙 우리가 이제 비대면 환경에 익숙해져서 성과를 공유하는데 이 미디어가 뭐 크게 어려움은 없지만 그 대면으로 보게 되면 좀 편하게 할 수 있는 얘기들, 뭐 고생했던 얘기들, 뭐 소위 에피소드에 관련된 얘기 그런 얘기들도 우리가 다 공유할 수 있지 않았을까. 어떤 면에서 보자면 아까 후배 학생들도 있다고 했으니까 그런 게 후배 학생들한테 오히려 더 가서 저기는 가서 공부만 하고 오나 봐, 아니면 무슨 과제만 해야 되나 봐. 이거보다 많은 학생들이 그런 측면에서 또 역시 마찬가지로 더 많이 성장했을 거라고 기대하거든요. 아마 워낙 사정이 안 좋아서 어쩔지는 모르겠지만 길 찾아 헤매는 경험, 뭐 식당 가서 뭐 주문하다가 뭐 등등 이런 경험들도 같이 공유할 수 있을 것 같은데 아마 오늘은 딱딱해서 그런 기회까지는 없을 것 같아서 좀 아쉽기는 합니다. 잠깐 여기에 덧붙여서 좋은 점들은 오늘 이 공식적으로 공유하시고 또 이민상 교수님이 워낙 이 프로그램에 대해서 잘 운영을 하고 계세요. 근데 뭐 다 여러분이 생활했던 것까지 알고 계시는 게 아니니까 우리가 내년 이후에 후배들을 위해서 보완할 게 있거나 또 현지에서 메슨 교수님이 아주 잘 도와주신 걸로 알긴 알지만 또 관련해서 또 뭔가 우리가 더 잘할 수 있는 게 있을지 그런 의견들도 오늘 행사와 상관없이 좀 들었으면 좋겠고 또 내가 듣기로는 여러분이 튜터 뭐 이런 걸 통해서 또 후배들에게 기여할 수 있는 기회가 있다고 들었어요. 이왕이면 그것도 적극적으로 여러분이 우리 사업단 후배들을 돕는다는 생각으로 좋은 후배들에게 역시 어떤 도움을 준다는 생각으로 마찬가지로 임했으면 좋겠다는 부탁도 드립니다. 일단 잘 들을게요. 뭐 시간은 많이 지났지만 무사히 잘 마치고 돌아온 학생들을 환영합니다. 네, 이상입니다.
네, 감사합니다. 네, 지금 이제 말씀해 주신 것처럼 네, 학생들 그런 경험담은 저희가 그 전공부에서 운영하고 있는 그 웹사이트를 통해서 네, 잘 기록해 놓고 네, 후배들도 많이 확인할 수 있도록 그렇게 네, 보완하도록 하겠습니다. 네, 그러면 우리 바로 우리 첫 번째 팀부터 우리 한번 발표를 네, 시작해 보겠습니다. 처음 팀은 네, 박은식 팀인데 박은식 네, 이 학생이 팀장이었고 네, 준비해 주시고 네, 준비되면 바로 시작하셔도 돼요. 박은식, 문정현, 문혜림, 이주영 팀이에요. 네. 발표 학생은 그 마이크를 다시 온 시킨 상태에서 해주셔야 될 것 같아요. 네.
들리실까요?
네.
발표 시작하도록 하겠습니다. Good afternoon. Thank you for joining here today. My name is Changyan, and we are going to start our presentation about what we have accomplished, which is focused on fallen tree detection based on UAV, and how we are going to improve our research in future. Our team members are Eun-sik, who is the team leader, Ju-young, Haerim, Do-yoon, who is the pursuing student, and me, Changyan. Our research aims to suggest a cost-effective way that small-scale farm owner and low-budget research can utilize to get their desired research. Therefore, while pursuing high-resolution images, data were collected using a cost-effective UAV. And in addition, we use the YOLO-X model to ensure the reliability of the detection results. The results analyzed by the models are present as a web-based visualization, which make it easy for anyone to obtain information about fallen tree. Different to any other YOLO version, YOLO-X implement an innovative mechanism called anchor frame detectors. Implementation of anchor frame mechanism with a follow modification not only reduce its speed, but also obtain better performance in its precision. Based on given advantage of using YOLO algorithm, this research conducts implementation of a YOLO-X algorithm trained by images in the most cost-effective way with timely manner. For this research, the data set was collected during 2 days period. The video was filmed at an altitude of 35 meters and 40 meters. Both data sets have been collected under decent weather conditions for filming. However, while we were collecting a second data set, it was difficult to collect an image with clearly identifiable route because of the heavy snow had been stacked. YOLO-X is a one-step object detection algorithm that simultaneously performs classification and localization process. Figure shows YOLO-X architectures. Figure here will illustrate the architecture of YOLO-X model. YOLO-X consists of the three parts: backbone network powered by Darknet 53, which extracts features, feature parameter network, which extracts feature maps at various scales and enrich them by changing its scale. Also, YOLO-X improved the average precision compared to the coupled head by applying the decoupled head manner that separates classification and localization into separate heads. As we mentioned in the previous slide, YOLO-X has a great advantage powered by its innovative anchor-free mechanism. Anchor-free mechanism calculates an area of certain object's existence using each pixel coordinates of the feature map based on the center point. Under anchor-free mechanism, hyperparameters related to predefined anchors are no longer needed. Therefore, each training and testing requires a relatively short period of time, and also required memory capacity has been decreased.
Now let's dive into implementation processes. During this conversion phase, the video was divided into 10 FPS frames. As a result, total 1,603 images have been extracted from those videos. When the tagging is done, a VUC format annotation file consisting of annotating information is exported. Next, this is example of dataset that we've annotated using RoboFlow. As you can see, class down represents completely lying on the ground. Class broken represent both broken tree and its stump. Class normal represent normally standing tree without damage. In our research, our definition fallen tree includes two classes, down and broken. After decompressing the exported VUC dataset, folders test, train, and valid are created as shown in the left figure. Each folder has both XML and JPG files for each image, and in XML file, the class name and coordinate value corresponding to each bounding box are stored. Among the YOLO-X models, the model was trained using pre-trained weights of the YOLO-X-X model that has the highest AP. The total number of trained data used in this model is 1,603, and the ratio of normal, down, and broken classes is 62, 35, and 2. As you can clearly see, our model trained by custom dataset has successfully detected target object. In the past, we found a difference in performance between YOLO V5 and YOLO-X, and the project carried out using the YOLO-X model. The table shows a numerical performance of YOLO V5 and YOLO-X. Even though YOLO-X uses a newly implemented technology and takes less time compared to YOLO V5, YOLO-X was 88% and YOLO V5 was 82%, showing YOLO-X higher than YOLO V5. In addition, compared to this result of YOLO V5, YOLO-X detected higher detection accuracy at the same confidence threshold, and above all, YOLO-X is 2.5 times faster in train speed. Therefore, the YOLO-X model was suitable for this study, which aims to detect fallen trees. For visualization, we use these tech stacks to provide web service for visualization. Front-end server received the images and send it to the server. Server analyzes image using trained YOLO-X model and returns the detection result to the client. At the same time, image is stored. Next. Previous. Okay. At the same time, image is stored in S3 database and result is stored in MySQL database. Let's see the demo video and then proceed with this flow above. Click. Also, we provide simple statistical information as well. This video uses dummy data. Our research itself is meaningful because there is relatively small amount of research out there that use combination of UAV collected data and YOLO-X to detect foreign trees. In addition, the results obtained through visualization tools can be used for agricultural insurance, government compensation claim support, and ecological monitoring. That's all we have prepared for today's presentation. Thank you for your attention.
감사합니다. 네, 화면 공유 스탑해 주시고 혹시 질문이 있는 학생들이 있을까요? 네, 지금 사실은 이제 영어로 발표를 해서 조금 놀란 후배들도 있을 수 있는데 학생들이 이제 미국 대학에서 이제 연구를 하고 미국 대학에 있는 학생들하고 같이 커뮤니케이션을 하다 보니까 사실은 결과 발표도 다 영어로 했어요. 그래서 오늘도 그때 한 발표를 그대로 재현하는 그런 의미에서 영어로 이제 발표를 하면 어떨까 이런 얘기를 했거든요. 질문은 한국말로 하셔도 돼요. 한국말로 하셔도 되고 이제 선배들이 대답을 해줄 것 같은데. 그리고 여기에 지금 여기 우리 학과에 관련돼 있는 사업단에 또 관련돼 있는 교수님도 많이 참가하고 계신데 혹시 네, 궁금한 점 있으시면 질문하셔도 됩니다. 네, 지금 좀 우리가 이거를 온라인으로 하다 보니까 발표자도 그렇고 저희 분위기가 좀 약간 침체돼 있는 것 같다는 그런 의견을 주셨어요. 그래서 네, 발표하시는 분이 좀 더 에너제틱하게, 액티브하게 우리 현장에서 했던 것처럼 그때는 아마 이제 앞에 관중도 있고 이제 동료들도 다 앉아 있고 하다 보니까 좀 더 그러셨을 것 같은데 오늘은 네, 되게 좀 캄다운돼 있다고 해야 되나요? 네, 되게 좋은 표현이고 네, 좀 침체돼 있다는 게 좀 안 좋은 표현인 것 같아요. 좀 더 네, 액티브하게 해주시면 좀 더 좋겠네요. 네, 그럼 다음 팀 바로 시작할게요. 우리 강혜종하고 최덕호. 나머지 두 학생은 지금 사실 4명이 한 팀인데 네, 지금 인턴십 중이라서 지금 온라인으로 지금 참여하고 있습니다. 네, 발표는 이 두 학생이 하기로 됐습니다. 네, 시작해 주세요.
네, 시작하겠습니다. Hi everyone, we are Team Idiots. We are presenter Haejong Kang and Doko Choi. Today we will be presenting on Node-RED-based pet-care IT platform. First, let me introduce my team members. I'm Kim, I'm Haejong Kang, and Seong Kim and Doko Choi are from Chunam National University, and Jiyeon-yu is post student. We will be presenting in the following order: introduction, literature review, methodology, development, and conclusion. First, introduction. You will see people with pets just by walking around the school. According to an institutional survey, the number of American families with pets is increasing. Therefore, the pet market is growing accordingly. Here comes the problem. There is a huge number of pet owners who have to work during the day, so they cannot take care of their pets during the time. To solve this problem, we decided to apply IoT in our project. As a result, we implemented 3 functions. First, automated remote feeding. Second, show feed and water consumption. Third, error notification. As shown here, there are already plenty of previous research on pet care IoT. So we created a new IoT solution named Specification. The name was created by combining the word pet and notification together. Specification made up for weakness of previous research and implemented its own platform using Node-RED, which did not exist before. At the same time, it became possible to utilize the advantages of Node-RED. First, via visual programming, we can implement our IoT solution much faster. Second, Node-RED is open source, so we can use unlimited features. Third, Node-RED can be run on various environments, not only cloud instance, but also Raspberry Pi. This is an overview of Specification. As MQTT is the main messaging protocol for Specification, each device is connected to the access point through Wi-Fi. Thus, all the messages published from devices are sent to the access point with Wi-Fi. And then they are sent to the platform through internet. The platform processes the messages and sends the processed data to the users in form of a web dashboard page, email, and WhatsApp message. On contrary, users can send the requests with the dashboard on the platform. While some requests require only the platform, the requests to activate the actuators are forwarded to the device with the help of the platform. In summary, users and devices communicate bidirectionally through the platform. The devices are the feed machine, and water supplier. To measure the weight, the scale as shown in the picture is placed on the bottom of the two devices. This scale consists of wooden board and load cell, which is a weight sensor. However, the feed machine, bowl, and container are placed separately. This is because each of their weight must be measured for functions to be implemented. So we use total of 3 scales. In addition, for the automated feeding function, this device was designed in the feed machine. It can control the gate using the servo motor. The platform for Specification consists of 9 blocks. MQTT message broker and database are running on independent processes, while MQTT manager, time series manager, rule engine, device manager, user manager, schedule engine, and UI dashboard manager are running on Node-RED. As a packet-wide solution, 2 devices are attached to the platform.
This section is development section and is divided into implementation and experiment. This picture is a part of our block implemented by using Node-RED. I'll show you just this dashboard block. These are the 3 main flows of our platform: food consumption, bowl refill, and error notification. Next is experiment part. There are 5 experimental photos and videos in this part. I'll explain while watching them together. The first is remaining experiment. The upper picture is a UI representing the remaining food. The lower picture shows the remaining water. Look at the remaining food UI. Among the gauges, the upper is a gauge indicating the remaining amount of food left in the bowl. The lower gauge represents the remaining amount of food in the container. In the remaining water UI, you can see the total amount of water in the bowl and container. Both food and water intake are graphically expressed at the bottom of the UI. Next is automated feeding. When the owner sets the amount of food to give to pass through the web UI, the servo motor attached to the gate operates and updates the amount of variation as the weight of bowl and the weight of the container continue to be checked. Next is food consumption. Due to the constraint that there is no puppet to help with the device experiment, so we made our own puppy for the experiment. If a dog eats like this, the weight of the bowl decreases, so the pet owner can see it on the UI on the gauge. As the food on the bowl decreases, its consumption is recorded in the food consumption graph. And if you look at the total consumption at the bottom, you can check the amount of food your dog ate during the day. Next is water consumption. Unlike food consumption, the total amount of water is expressed in the gauge. In the video, you can see that the gauge decreases every 3 spoons. As before, the pet owner can know when the pet consumed water. Through this part at the bottom, the pet owner can check the total intake. The following is an error notification experiment. Look at the UI. The state of the device changed to the red light, and at the same time, it changed to a food empty state. If such a sudden error occurs, the pet owner can receive notification on the phone by WhatsApp and email. This is our conclusion. The researcher result is that we made an IoT platform by using Node-RED. This platform could be used by people raising pets. Limitation is that we could not exactly control the amount of food per second come out from container. The cause of limitation is that we use the gate method. So in the future, we have to improve the device function, allowing a certain amount of food to come out. These are our references. Thank you for listening.
네, 감사합니다. 재밌는 프로젝트를 진행했었는데 사실 지난 결과 볼 때도 우리 되게 즐거워하면서 봤던 것 같아요. 네, 손으로 간. 실제로 우리 결과물들을 어떻게 활용하고 있는지 모르겠네. 다음 팀은 준비해 주시고 혹시 그 사이에 질문할 분 계시면 질문해 주시면 좋을 것 같은데요. 지금 네. 그리고 발표 준비한
질문 없으면 내가 질문 하나 할게요.
네.
해도 되죠?
네, 질문해 주십시오. 네.
아니 아무도 질문 안 하니까 제가 질문하기 시작하면 안 할까 싶어서 아까는 안 했는데 이렇게 그냥 제가 궁금하기도 하지만 뭐 질문이라는 게 다른 게 아니고 이렇게 쉽게 소통할 수 있다는 걸 보여주기 위해서. 저기 아까 장치를 만들었잖아요.
네.
물하고 저기 뭐라고 표현해야 되지? 하여튼 그 장치에서 특히 물이 그렇게 보였는데 그 펫이 그걸 넘어뜨릴 수도 있고 오히려 난장판이 될 수 있어서 그런 CQ하기 위한 아이디어가 있었는지 뭐 지난 발표에 제가 참여하지 않아서 그런 부분 누구나 할 수 있는 질문 같거든요. 그런 부분까지는 그냥 IoT만 생각하고 고려하지 않았나요? 혹시 궁금해요.
네, 고려하지 않았습니다. 그냥 일단은 정상태로 있는 상태에서 물이 줄어드는 것만 확인하는 형태였습니다.
네, 그래도 재밌게 봤습니다. 네, 수고했어요.
네.
감사합니다.
아마 그때 그 K-스퀘어에 실제로 큰 덕이죠. 강아지는 아니고 이제 큰 개가 있었는데 아마 실제로 사용했으면 아마 또 다른 지금 그 단장님이 말씀해 주신 것 같은 그런 것도 아마 고려했을 수도 있을 것 같아요. 근데 아마 조심스럽게 손으로 하다 보니까 우리 그런 것까지 고려 안 했어요. 그죠? 네, 감사합니다. 그러면 다른 그 지금 참가자분들도 질문할 거 있으면 자유롭게 질문하셔도 돼요. 네. 네, 그러면 우리 다음 팀 노아영 한승호 팀 우리 진행해 주세요.
혹시 화면 보이시나요?
네, 잘 보입니다.
Yes. Hello, my name is Sungho, and the topic of our project is enhanced human detection YOLO X for search and rescue. Our team consists of 5 members. Sungho and I are senior from Chungnam National University in Korea and major in computer science and engineering. Ben, Jake, Kiss are from Purdue University. The main reason of this project is to search and rescue people who get lost in the forest. Usually human resources are necessary for quick and effective search and rescue. However, this method has the weakness of being time consuming. To fix this, recently UAVs are used to support without visiting directly. But even UAVs have their own problems, which is when a UAV goes higher, the smaller object look, and this makes deep learning models have a difficult time detecting human. So we came up with this idea of improving model to fix problem when using UAVs to search and rescue people. There are 3 main contributions, which is our novelty as well. We propose attentive feature pyramid network to focus on detecting small objects and propose a new data augmentation method to improve detection accuracy. Also, new images are taken via drone. We are mainly focusing on the improvement of model based on deep learning. In this part, I introduce the proposed method that we have implemented and designed. Before I show our model, I present a sample image about object detection. It includes detection result over different types of objects. Object detection can find the location, class, and probability of object, as this sample image shows this. In this research, our purpose is to find people in search and rescue based on object detection mechanism. Basically, our model uses YOLO X as a baseline network. For our research, we have tried to improve from the baseline network. And I explain overview of our model. The model consists of backbone, neck, and head. First feature is extracted from the backbone network, named as darknet. The neck uses feature pyramid network, the famous structure in field of object detection, to consider multi-scale objects. Low resolution level is used to detect large-scale object, and high resolution level is helpful to detect small objects. However, existing this part from YOLO X use only 3 levels, such as P1, P2, P3. So to increase the level to detect small object, we add a new level of feature pyramid network and design this part. We should have considered how to make a new level using existing information. It is our novelty compared to the existing YOLO X. Each level is connected to the head. Head part has results such as class, coordinate of bounding box, and confidence score. We propose the method to make a new level of FPN. I show this picture. How can we make a new level and why we're doing this? P1 is high resolution level, which include information of small object, and P2 is low resolution level, which has information of entire image scene. So P0 is made by fusing these 2 kinds of information, and we add 2 models to these 2 features. And we use a self-channel attention model before forwarding to the head, shown in upper figure. Self-channel attention means focusing on specific features of hidden layer by giving weights in the channel of features. It makes more efficient to train the model from many features. It just means a model can select adaptively features. We prove the proposed method in the experiment. First, and I introduce our training data set. SAR dataset is the first image dataset in search and rescue on drone. We divided total images into 8 versus 2 for training and validation. Heridar is another dataset, and we take some image. The number of images 2000 is not big number to train a model, so we are going to create our own dataset to improve the model. To validate our method, we could show self-comparison about each method. First row means YOLO X baseline, and second line indicates extended additional level of the neck. Next row indicates effect of self-attention model. Last part is to add data augmentation algorithm. We have implemented many architecture and comparisons with a different version will be added when we when we submit this paper. To show how our proposed method can be used in main search and rescue scenarios, we built our web for visualization. There will be front-end, back-end, and map APIs to plot detected person's location. We are using .NET 6 for our API. Let's watch demo. Purdue student made this web visualization. Each image shows the location where we take this picture, and the description of our project. Our plan after this program, we will adapt new data augmentation method into the model to show the better performance. The second, we will implement different version of YOLO to compile and show YOLO X with our methods. Greatness. Next, finally, we will submit our paper on the international conference this year. Thank you for listening to our presentation. If you have any question, please ask freely.
네, 감사합니다. 네, 지금 아마 이게 이제 참가하시는 분들이 궁금해하실 것 같아요. 지금 저희 첫 번째 두 팀에는 포주 학생이 1명이었는데, 여기는 3명이나 있네요. 네. 그리고 첫 번째 두 팀은 사실은 한국 이름을 가진 그 퍼주 학생들이네요. 이렇게 궁금해하실 것 같은데, 사실 퍼주 학생들이 이 프로그램 전체에 이제 지원을 하면 그 학생들도 본인의 의지를 가지고 이제 프로젝트를 이제 지원을 해요. 그러다 보니까 좀 인기 있는 그 관심도가 좀 높은 프로젝트에는 좀 학생들이 좀 여러 명이 지금 지원이 된 것 같아요. 그리고 첫 번째 있는 두 학생들도 교포 혹은 뭐 유학생인 경우도 있더라고요. 그래서 이제 그렇게 이제 배정이 돼서 이거는 뭐 특별히 어떤 지정한 게 아니라 학생들이 그렇게 선택을 하다 보니 좀 이렇게 일률적으로 배정이 안 됐다는 점은 좀 알고 계시면 좋을 것 같아요. 네, 그러면 다음 프로젝트 다음 준비한 팀도 좀 준비해 주시고 혹시 뭐 궁금하신 게 있을까요? 네, 궁금하신 게 있을까요? 질문을 좀 많이 하면 좋겠는데 우리 후배 분들은 질문하실 게 없을까요? 네, 일단은 혹시 이제 쑥스러워서 질문을 못 하시면 질문을 좀 채팅방에다 좀 잘 남겨주세요. 그러면 저희 종료할 때쯤에 다시 한번 Q&A 시간을 좀 더 가져보도록 하겠습니다. 네, 그러면 박지우 팀이죠? 네, 박지우 팀 시작해 주세요.
Hello, I'm glad to give you the final presentation on our project called Dynamic Parking Spot Allocation based on the web. Next. Before we start, our team's name is Peter Parker, which consists of 5 members, Jiu, Jeongkyun, Byung-gyu, from Korean Chungnam National University. And then Haja, who our project student, has helped with this project. Next. the presentation will be proceed with these 5 sections. Next, parking problems. According to this data set, the number of registered vehicles are constantly increasing in the United States, which causes parking problems. Next, to be specific, the issues arises from the fact that private vehicles spend most of their time being parked. There is not enough parking space to accommodate overflowing vehicles. And 30% of traffic is caused by insufficient parking space, followed by vehicle emissions. Next. In order to address parking problems, we conduct dynamic technology. This technology offers 4 features: simplicity, flexibility, economy, and convenience. We start by providing an intuitive user interface in the web so users can easily handle the product. Next, an administrator adjusts parking spots flexibly according to the demand. Then our product can be installed to any parking lot and utilizes the limited parking space so that users can save the money. Lastly, the administrator will manage the parking lot as well as allowing users to check the seat availability in real time. Next. As our parking system can be conducted in the best way, we compared and analyzed similar technologies. There are 4 methods that we have investigated. From the top, they consist of algorithm to IoT systems, and each of these systems featured in terms of mathematical calculation to real-time data sharing. Among these systems, we adopted the IoT system to adjust the information in real time. Next. In order to implement our system, we have used a number of different options. In terms of platform, we have chosen Node-RED over ThinkBoard because it is more compatible with other devices. In the main board, between price and performance, we chose Arduino as our system does not require higher performance. In terms of modules, LCD display, RGB LED, and infrared sensor were chosen in accordance with the project. The technology is made available to customers via the web, so they can use it on any devices. Next. With the devices that we chose, here is our system overview and hardware interface. After all the aforementioned modules are installed on the Arduino and Node-RED are interconnected. Once they are linked, Node-RED controls all devices, including web pages, as a platform. Next, in the hardware interface, we use one Arduino supplying power with USB to connect 8 infrared and LED RGB modules so that it can accommodate 8 parking spots. As for the parking lot entrance, the LCD display module is installed to check seat availability. Next. In this flowchart, we show our process of the parking system. First, the system administrator assesses the manageable web page and initializes parking spot status. After the data is updated, the system will recognize its duplicated value. If there is no duplicated value, the parking data will be updated when a parking spot is changed to a different color. An infrared sensor will then count how many cars are parked. In addition to the web page, all this updated information will also appear on the LCD display. I have been handling this part until now. From then, GeoPark will take over.
Hello, I'm GeoPark, and I will explain experiment we did with our system. The first step is to connect each module to the Arduino. The image on the left side is the modules we will be using. The second step is to upload the basic setting to the Arduino by using a program which is called Arduino Sketch. During this step, the while iteration is executed when the Arduino is on, and there are 3-4 iterations. First, in the through 4 iterations, the Arduino sets the RGB LED modules, And in the red 4 iterations, the LCD display will be updated. And lastly, in the green 4 iteration, the IR infrared sensors value is checked. The third step is to use the Node-RED, which is platform, is to use to connect system Arduino and computer that allows the system to receive the signal. During this step, there are web nodes which consist of JavaScript, CSS, HTML is connected through the HTTP node. And after this process, the Arduino can interact with the system by using serial node. And WebSocket node makes the web node to communicate each other. As for the first step is to manage a web page. The left side of the web page is control options. Manager can set data value by using these control options. And the center part is the graphical schema that display the parking lot. And I will be explaining each part. This is color setting. When the color setting is clicked, it will be changed into color setting mode. And after selecting each parking spot and selecting color, the section list will be updated. This is control of the sections. A plus button will be displayed left top side on the web page. It allows of adding new parking spot to the data set. If the data were to be added successfully, the section list will be updated. And next is changing and removing the data. If the manager click edit button that next to the add button, the section list will be changed. And also color, when the color is clicked, color will be changed and the name may also be retyped. Also, the manager can easily remove the data by clicking the remove button that displayed in the list. All of the change will be saved if the check button is clicked that display at the bottom of the section. And there are reset button that allows manager can easily reset all the data. And lastly, if the vehicle is parked in the parking spot, the manager web page will mark with the icon. Fifth step is to make a user web page. Not only it adjusts automatically the screen of the size, but also the parking lot information will be updated in real time. The sixth step is to make a sample model. In order to test our system, we make a sample model that has 8 parking spots, and each modules will be placed on each parking spot. Lastly, the final step is to make a connection between the sample model and our system. Here you can see how our system works. If the manager web page set the data and user web page, then sample model will be updated. And on the other hand, if the vehicle is parked in the parking spot, it sends the data to the manager web page. This is our analysis. We conclude 3 problems. The first problem, our system limited to indoor parking lot only. And next problem, the sample model is different from the real world. And there are problems with the visibility of RGB LED module. As for the result in this system, when events occur, each parking spot can be flexibly allocated, which allows the driver to park at unused parking spot. That, as a result, can allow more vehicles can be accommodated by using our system. This is our future plan. We plan to solve the problems that we talked about the previous slide, applying rules and standards from the real world and making the LED light more visible in the outdoor parking lot. Thank you for listening. If you have any question.
네, 감사합니다. 네, 혹시 질문 있을까요? 학생들은 아마 네, 파킹랏에 그닥 네, 관심도가 좀 떨어질 것 같긴 한데 혹시 교수님들 중에 궁금하신 거 있으실까요? 네, 일단 그러면 질문은 잠깐 네, 홀드하는 걸로 하고 다음 팀 준비할까요? 우리 광미래, 김희정 준비됐을까요? 사실 저는 오래된 아파트에 살아가지고 관심이 되게 높았는데 네, 진짜 파킹 문제를 해결하지는 못할 것 같긴 해요. 그죠? 네. 좀 더 자세한 뒷얘기는 네, 끝나고 다시 들어보도록 하겠습니다. 네, 다음 팀 준비됐으면 네, 얘기해 주세요.
네, 시작하겠습니다. Hello, we're Team 3 Crowful, and I'm presenter Riel Kwak. We will talk about Georgie driving prevention IoT system by waking up driver through responsiveness check. We will present our project with the following order. First of all, team introduction. These are our co-full makers, including team leader Geong-jung, Shin-young-bo, Ye-sung-lee, Hee-jung Kim, and Purdue student William Park and Alex Choi assisted our research. Next is our main topic. Our main topic is designing a prototype of an IoT system to wake the driver up through responsiveness check. We designed a wrist-wearable device to detect drowsiness by monitoring the driver's heart rate and SpO2. When heart rate and SpO2 is under the personalized threshold, it is determined that the driver is in drowsy condition, and the device gives the vibration. Then the driver responds with sound, and the mobile application checks the response time. Next is our introduction. As you can see, according to the survey, drowsy driving is a serious concern for the driver. In related works, there were limitations that the driver could run the constant patterns, and the game operates at the driver's will, resulting in poor effectiveness. To resolve the limitation, we applied random patterns and auto-starting game. Unlike the previous system, our novelty is as follows. The following graph shows the reaction time in the normal and fatigue state. As you can see, the reaction time is longer in the fatigue state, increased by 11.7% than the normal state. This indicates that the responsiveness factor can be used for monitoring the drowsiness. To increase the driver's participation, the terminology of gamification is implemented. Simple voice task is used to check the responsiveness to the vibration stimulation. Depending on how fast the driver responds, mobile application provides different voice feedback such as good to slow, wake up. Next is our project specification. This is our overall system flow chart. It can be divided into the detection part and the game part. When driving starts, the system initializes the threshold value for personalization. When drowsiness is detected, the game starts. In the game part, the system checks the driver's vocal responsiveness from tactile vibration. According to the response, the application gives different voice feedback to driver. If the driver is in drowsy condition, the game continues. Otherwise, the game stops and go back to the detection part.
From now on, I will continue the presentation. This is the flow chart for initializing the threshold. Heart rate and SpO2 are calculated for 10 minutes, and response time is calculated 10 times to determine the threshold. Here is our Wwd Circuit Design and Pseudocode. It is designed as a parallel circuit. And the pseudocode on the right briefly describes the logical flow of the Arduino's code. During 4 seconds, the raw data for heart rate and SpO2 are measured and calculate the average heart rate and SpO2. To remove the noise, low-pass filter is applied. Through BLE communication, the data is sent to the application. While measuring, when a vibration signal is received, the vibration motor operates. This is the prototype picture of our Wwd. Here is our Wwd Circuit Design. This RPC handler rule engine switches its RPC messages and executes them. Each process makes the RPC's reply and return to the client. If the parameter exists, the ICP makes a post message to save the data. If the sign of warning is detected, like drowsy detected or slow response, the alarm is created for visualization. When the application sends a request, the ICP determines condition by this following code. As you can see, there are 3 different conditions. So different sound files are played by ICP decision. Application connects between the ICP and the Wwd to transmit data to each other. Application is connected to Wwd through Bluetooth and to ICP through RPC protocol. We use React Native to implement application. This is the demo video shows a normal situation. The application sends bio data to Dashboard. At Dashboard, you can see the collected data. And we used our finger, not wrist, to visually show the sensor is working. In this demo, you can see when drowsiness is detected, the application starts the game. After the vibration, driver responds with voice. According to the condition of the biodata and response time, the application gives the voice feedback. Let's see the video.
Wake up. Too slow.
This is our conclusion. The effects of our IoT system is, first, induce the driver's participation through gamification. Second, improve the awareness of drowsiness. Last, the game repetition awakes the driver from drowsy driving. Through these 3 effects, our main goal, drowsy driving prevention, is expected. Finally, further discussion. First is the lack of accuracy in detecting drowsiness. The sensor MAX30102 official library has a problem with measurement, so we developed our own method. However, the accuracy is unverified. Therefore, our methods such as machine learning can be used for increasing accuracy. And the voice task cannot fundamentally relieve fatigue. The main goal of our study was to increase the driver's alertness and awareness, not to reduce fatigue. Inducing people to stop driving and take a nap, which is the best way to reduce fatigue, can be implemented for further development. Thank you for listening, and if you have any questions, feel free to ask. Thank you.
네, 감사합니다. 네, 혹시 뭐 질문 있으실까요? 재밌는 프로젝트였는데, 네, 결국 해결책은 네, 스탑하고 네, 슬립하는 거 이렇게 제일 좋은 해결책이긴 하네요. 네, 일단 네, 또 궁금한 거 있으시면 질문을 해주면 좋겠는데, 네, 우리 후배분들은 아무래도 내용 질문을 많이 안 하시네. 네. 일단은 네, 다음 우리 사실 뭐 포디에서 있었던 얘기도 아마 질문하실 수 있을 것 같아요. 네, 그런 얘기는 그러면 우리 프로젝트 설명 끝나고 소개 끝나고 계속 하는 걸로 하고 다음 팀 진행할게요. 우리 다음 팀 최지수 이동원 팀인데 준비되면 네, 화면 공유해 주시고 네, 바로 시작해 주시면 될 것 같아요. 네.
Hello everyone, I'm Jisoo Choi from Team 4 Guys. Today we will introduce our project, IoT system for measuring shot group using LoRa and YOLO V5. Here are our team members, Sang-hyun Park, Do-yeon Go, Dong-won Lee, Jisoo Choi from CNU, and Jae-gen Noh from Purdue. First, I will talk about problems we faced and the goal we aimed for. Then we will see brief overview about our project, Shot Tracker. There is a demo video and implementation and experiments we did will be presented. Let's talk about shooting. You guys might have seen shooting in Olympic or military service. Moreover, there are a lot of people who enjoy shooting as sport. Shooting is common, popular, and has a huge market. Every shooter wants to improve their shooting skills, so first they need to measure their shooting performance. There are two factors for measuring, accuracy and precision. I'll skip the detailed explanation, but the most important thing is we measure one's shooting skill with the shot group size from the target. Then let's see these pictures. How will you check your target? Of course, you cannot check your target between your shots because it's too dangerous, especially if there are other stars in the same area. Things get harder when it comes to long range. Usually there is one way. Shoot first, being aware of your score, and after the game, go to retrieve your target with your car or foot. And finally, measure the shot group size with your ruler and do some math and write down your score. Wow, it's too annoying. Because this process is too annoying, there are some commercial services for this. Shot marker is acoustic system, Kongsberg is electric system, hardware shooting is camera system, and Ballistic X is mobile application. However, each has its own drawback. Shot marker totally depends on sound. Sometimes results are far from the actual results. Kongsberg needs expensive preset like electric target and cables. You should buy and install them. Hardware shooting is actually just target streaming service using Wi-Fi. It doesn't detect or calculate anything. Of course, you need to be in the Wi-Fi zone. Ballistic X is not a system. It's an application which calculates shot group size for uploaded picture. So let me introduce our project, Shot Tracker, the IoT system for measuring shot group. It solves all the problems so far. First, it doesn't require internet connection. It can handle distances more than a mile. And it provides real-time black detection and automatic shot group size calculation. Users can get an actual target image. Even more, it has a reasonable price and is easy to install. This is our system's architecture. It consists of 2 PIs and user application. When you pull the trigger, Pi with sound sensor detects your gunshot. It sends the command to another Pi next to the target to take a picture. This pie then takes a picture of the target and warp the picture to be straightened using its reference image and detect bullet traces. After our processes are done, it sends the coordinates of traces to the Raspberry Pi with sound sensor. The mobile application reflects these points via Bluetooth. At the end, Pi with the camera sends the actual image of the target so users can see what really happened. Let's see our demo. We simulated shooting with clap sounds and screwdrivers. You see one clap and one shot detected. And second clap and second shot detected. And so on. Focus on these pictures, please. The first picture is what our Pi camera actually captured. We warp it to second image. Then we calculated the shot group size and present the result to the user. You can see here, the results are very similar. It's quite accurate. These are technologies we used for shot tracker. Dong-Hwan will explain these and our experiments in more detail.
Hello, I'm Dong-Hwan Lee. I will talk about implementation. We use LoRa for communication between the two Pis. It can reach over several miles, so shooter can receive the data far away from them. It consumes less power, but it has low throughput and small payload. Bluetooth takes part in transmitting data between Pi and a mobile device. By using Bluetooth, user can check their target without an external internet. It has high throughput and consumes low power. For more battery efficiency, we build a new socket connection before every use. The sound sensor is the trigger of sending a signal when it detects gunshot sound. Sound threshold is controlled by a 10 kilo ohm resistor. To detect bullet traces automatically, we use the YOLO-V5 nano model. We trained our model with 260 images and 2,578 annotations. It has 0.62 MAP. Like these images, YOLO detects bullets and produces the coordinates. So how can we measure the shot group size using YOLO-V5? We solved this problem with image warping. We set reference and actual image for feature matching. We implemented image warping with OpenCV, where we extract image features from two images. The Ransack algorithm finds the metrics for image warping. We got a warped image like this. We use a simple proportional equations between pixels and inches for calculating. This slide is the main and selecting the target page in application. If the user is shooting the gun, the user can check where their bullets are. When the user clicks the finish button, the application calculates the shot group size and receives a real target image. This image shows receiving the target image using Bluetooth. Also, user can manage their shooting history. We did experiment indoor and outdoor. These two pictures show the indoor experiment setting. This page represents the best result indoors. The accuracy is over 80%. Our system showed amazing performance in indoor experiment. This page represents image transmission doing well using Bluetooth. In outdoor experiments, our system didn't receive coordinates. The image worked poorly, so YOLO cannot detect bullet traces. The reason is the background feature. The sign behind the target has image picture. This is another experiment's result. It detects bullet traces, but it was wrong. Shadow disturbed image warping. We believe our system will show better performance outdoor with further research. In conclusion, our system, shot tracker, can detect bullet traces real time and measure the shot group automatically. We build a system with cost-effective and low power consuming parts. Finally, this produces the actual target image. We hope it can help shooters who want to check their shot real time. Thank you for listening.
네, 수고하셨습니다. 네, 재밌는 프로젝트들을 다들 진행했죠. 네, 사실 뭐 여러분들이 지금 샷 이런 경우는 우리 아마 생각하지 못한 학생들도 많이 있을 것 같아요. 네, 뭐 진짜로 이것뿐만 아니라 다른 쪽으로 또 어플라이 수 있는 부분도 많이 있어서 네, 재밌는 프로젝트들을 진행한 것 같아요. 이 팀뿐만 아니라 다른 팀들도 다 마찬가지인데 지금 사실 우리가 2달 동안 퍼듀를 방문하는 바람에 좀 어떻게 보면 길기도 하지만 사실은 프로젝트를 완성하기엔 조금 약간 짧은 부분도 없지 않아 있었을 거예요. 아마 그래서 아까 어떤 그룹이었나? 네, 계속 뭔가 이렇게 후속 작업을 뭔가 이렇게 한다고 했는데 아마 그래야지 더 좋은 그 논문으로 작성해서 아마 연구 결과를 발표하는 그런 형태가 되지 않을까 싶네요. 질문 있으시면 네, 중간에 스탑하고 질문하셔도 되고, 네, 아니면 지금 다른 팀, 네, 김남호 류건열 팀, 네, 준비해 주시고, 네, 바로 시작하셔도 됩니다. 네.
Hello, I'm Namo Kim, and our team is Maknae on Top. Our project is an optimization route guide for indoor fire verification using beacons. These are the team members: Minsu-sun, Jun-sung-moon, Konyeol Ryu, Mi-kyung Kim, Namo Kim, and Sarah Honi from Purdue. Our presentation followed this index. According to the US Fire Administration, 39.3% of recent fires are indoors. To prevent accidents involving indoor fires, this research was conducted by developing an app that informs the optimal route for indoor fire evacuation by using beacons. In previous study, there are research results that improve the accuracy of positioning by an average of 5 indoor measurements. However, there are limitations in existing studies. It only takes into account location data, so it is not possible to consider how many others are gathered. Moreover, studies on accuracy improvement have limitations that it is difficult to use in other buildings because it was measured only in specific buildings. For this purpose, the detailed goal of these studies are these: use beacons to determine the exact location of the user in the building, and develop the user-friendly applications such as informing users of the beacon's installation location by providing users with the ability to upload and modify building blueprints. Identify the density of people in the building and calculate the weight value to inform the optimal path. The methodology is this. When the manager uploads the blueprint for each floor, the server converts it to the map. The user's location data is obtained using iBeacons. The application displays the fastest optimal route from the current user location on the map, considering the current population cluster. Grading is done using OpenCV, and the pixel is divided into two values using Achu algorithm. We selected the threshold when the contrast distribution of pixel values are most uniform. After that, the inner element was deleted and the remaining noise was removed by the denoising function. To measure the position, the trilateration method was performed using the distance from the beacons. So calculating distance with the signal value sent from the iBeacon is needed. The iBeacon has TX power and RSSI. So using the formulas 1 and 2 on the screen, the linear distance from the beacon is calculated. Trilateration needs 3 beacons coordinates, so at least 3 beacon installations are required. Through this, we can get the user's current location coordinates. But the calculated location is not accurate because of the noise by differences in signal density. To solve this problem, an estimation model is created for each building. To create an estimation model, coordinates are measured several times at one point where the beacon is installed. Through this estimation model, we can increase the accuracy of location. Next, route recommendation algorithm. This algorithm was designed to show the optimized route considering the position of the other users in the same floor. The formulas presented in the existing study do not consider the number of people, so we use the new algorithm. The formula is this. The function g is the cost from the start node to the current node, and the function h is the heuristic that uses the Manhattan formula without the cost from the current node to the target node. And the function f is total cost. This picture is the operation process of the algorithm. In step 1, you can see the numbers in the block, which is the result of the function f. A is the starting node and B is the destination node. Among the A nodes around the start node A, the direction node which has the smallest number is selected as the next search node. Once this is completed, the calculation is repeated until reaching node B, like step 2 and step 3. Selected nodes can be route, like step 4. And from now on, I'd like to hand it over to Konya.
건열 학생 마이크 꺼 있는 것 같아요.
죄송합니다. I'll explain about our implementation. First, we installed 3 beacons in the KSW scale building to be able to calculate user location. Users can enable the iBeacon scanning feature on their mobile device to scan the beacons on the building. The mobile device receives the beacon signal and sends a beacon list, which is close to the user, to the server with the building UUID. And the server does its filtration to figure out the user location. When the flame sensor detects a fire, the node MCU sensor notifies the server that the fire has occurred by sending an HTTP request, and server notifies the app and sends the optimized route to exit, like this image. In this study, the operation process server is shown in the figure. There are 3 main functions. First, the location measurement uses a list of device ID and beacons. Next, coordinate data are obtained from the database in the order of the nearest distance. Through this, the coordinates of the nearest beacon can be found, and the trailer duration calculates the user's location based on the imported beacon information. The calculated user's location is updated in the population table of the database. The blueprint send function uses the UID and floor data to load the image of the flow from the database. And the image is encoded and stored. Image files and imported data are sent to the app. The blueprint save functions use image data. In order to recognize the image of the blueprint, a Python code capable of removing noise is executed on the server, and then image data is stored in the floor table of the database. These are our application screens. Blueprint management can only be performed by a manager logged in from the application. After unloading the blueprint, the manager input the floor, the name of the building, and the UID of the beacon. In the list of unloaded blueprints, if the blueprint list is slid to the left, it can be modified after checking the information on the blueprint. And if it is slid to the right, the blueprint can be deleted. In a set of coordination on the unloaded blueprint, it is used to set coordinates such as toilets, axes, and room names. This setting can be used as a destination. And a guide optimal route service can be used by all users. In general situations, the optimal route from the user's location value obtained by the distance set by the user is calculated and displayed in real time on the screen. At this time, it guides the best route considering population density only for application users in the building. When a fire event occurs, this application can detect real-time fires using WebSocket with the server. And if a fire is detected, when the fire detection notification is on, it automatically guides the optimal route out from the current user's location. In this study, an application for optimal route guidance was developed. Currently, indoor fires are occurring at a high rate in society. In order to solve this problem, the location of the user was measured using beacons, and the optimization path was guided. This study is summarized as follows. First, an estimation model was used to measure the exact location of the building. Second, a manager page was added to recognize the image of the building blueprint and to consider obstacles. Third, the optimal escape path was suggested by grasping the degree of concentration of people. This study is significant in that it improves the accuracy of location measurement and develops user-friendly apps. However, it shows limitations in that there are no many measured data sets in various buildings. In addition, errors in the indoor position measurement value occurred occasionally. This is an error caused by the beacon sending a completely different signal value as data is quickly communicated in real time. So an error occurred in route guidance through rate calculation of all personnel. As indoor location measurement using beacons is gradually developing, it is expected that more various conditions will be considered. Also, research on a user-friendly position measurement system will be conducted in various environments. These are our references. Thank you for listening.
네, 감사합니다. 네, 지금 Future Studies라고 이렇게 나왔는데 조금 더 보완하면 정말 좋은 연구 결과로 만드실 수 있을 것 같아요. 지금 처음에 이제 소개했을 때 그 참여 학생들이 많이 있었었는데 우리 이 팀은 특별하게 이제 제주대학교에서 온 학생들하고 같이 그룹이었던 팀이에요. 그래서 우리가 이번에 퍼듀 방문할 때 우리 학교 학생들만 간 게 아니라 다른 학교 학생들도 갔거든요. 그래서 그 제주대학교 학생들이랑 또 그 연세대학교 미래 캠퍼스에 있는 학생들이랑 다 같이 이제 조인을 했는데 우리 팀이 그랬고 지금 이제 마지막으로 이제 발표를 하게 될 우리 지금 강시원 학생이 준비하고 있는데 우리 그 강시원 학생 팀도 대부분 이제 제주대학교 학생들이 많이 있었어요. 네. 시원 학생 어떻게 지금 준비됐을까요? 준비되면 바로 이제 화면 공유해 주시고 시작해도 돼요. 네.
공유 잘 됐을까요?
네, 잘 보입니다. 네,
네,
목소리도 잘
시작하도록
들립니다.
하겠습니다.
네.
Good afternoon. I'm Xiong Kang, a presenter of the New Wave team. I'm going to present our project Establishment Wireless Intranet Network and Development Web Application for Disaster Area using UAVs. The presentation will be in this order. First of all, I will introduce our team members. Pigyo is the leader and Jiun and Alec develop network and Xion, Ijun, Juhyun develop web application and Haewon support paper. Every year, there are many natural disasters like a volcano eruption, tsunami, earthquake, hurricane. This picture of the Tonga's volcano eruption last month. In this disaster, Tonga lost communication cable. So relief activity was limited and people panicked. Satellite, balloon, cow, various methods are being studied to recover communication networks for disaster situation. First, using a satellite. Satellite communication networks have a wide range, but range cost is extremely high and must need specific device. Second solution is using balloon. Low altitude balloons have relatively wide coverage and long runtime, but we cannot control balloons, so we cannot fix the balloon in one position. The next one is using a car. It's easy to set up, but the coverage is influenced by obstacles like a building. Provide intranet communication network and web application for intranet. So we suggest providing an intranet using drones. The drones goes with an AP and antenna to provide a Wi-Fi intranet network. This picture is the drone we made. We developed a web application for intranet service, for example, chat and video call and map and alarm service. Our novelty, rapidly provide and web service and use exciting devices. Our novelty is these three. We can provide our service rapidly, bring drone and some equipment, and we can make communication network. Previous study just suggests network methodology, but suggest how to use the network. And we can use exciting device because we use Wi-Fi to provide the network. From now on, I will talk about network part. The goal of the network implementation is to provide Wi-Fi coverage for web application within a radius of 500 meters and to increase web application accessibility through DNS server. However, some implementation methods have been changed after the midterm presentation. Previously, we planned to provide user authentication service through 802.1x authentication and radio server. But due to the Cisco AP's technical support period has expired, changing and saving setting in AP GUI does not work anymore. So we decided to implement user authentication through a web application. Now let me explain the network topology. New wave network is divided into ground segment and area segment, as shown in the figure. The ground segment consists of router, switch, servers, and power supplies and is located on the ground. The area segment consists of the AP and antenna and is installed at the bottom at the UAV to transmit wireless signals to the ground. Ground segment and area segment communicate through UTP cable, and power is supplied using PoE. In previous experiments, we measured the performance of the antenna using the Cisco 3702 and Ubiquiti AM V5G Ti. The average speed was 6.76 megabps and the maximum speed was 16.30 megabps at a distance of 150 meters. The field experiment was conducted to verify the stable operation of the area segment mounted on the drone at the verified that power is supplied stable from the ground. The test device is as follows. The altitude of UAV was set at 50 meters in consideration of the weather condition and safety, and the distance between clients was 140 meters. We used iPop for measurement, and the test was run on 60 seconds with a 5 megabyte window size using the TCP protocol. TCP session was set in 3 cases. We used the average as the result after 2 measurements, expect 8 session tests. The AP and antenna setting is as follows. This is an experimental video. Here are the experiment results. When using one session, the average speed was 12.31 megabps and the maximum speed was 32.1 megabps. Here are 4 sessions. The average speed was 13.87 megabps and maximum speed is 26.3 megabps. Here is an analysis of the experiment result. We found that our requirement operates stable at the altitude of 50 meters, and power was stable supplied to the area segment. We checked the average transmission speed was 10 megabps or higher. We found those slowdown in some section of the A session test because the temperature was lower than the AP's temperature range. And web application part. By using Kakao Olive to verify the license of the defendant packages, we decided to distribute this project under the MIT license. The license for the packages were notified on the notice page. You can use the UUID packages to create a room and use the chat service through socket communication in each room. We use Refred on open source libraries that utilize maps. Our user may download and provide the OSM public transport map so that they can retrieve the map without an internet connection. When a user is in danger, if the user presses the SOS button using the notification API, the user's name card turns red. When a specific user sends the join num to the server using socket, the web server receives the peer information from the peer.js broker server and send it to the user. The video call function is the heaviest among the service provided. Using this method allows the users to communicate in a P2P manner without being processed by the server. This is a demo where video calls were actually tested outdoors. A test was conducted to find out how many packets are used by each service using a packet analysis tool called Wireshark. Client was 80 meters away from the location, but the connection was not smooth from the laptop's antenna, so no useful result was obtained. So we narrowed the distance and proceeded with test B. The test was conducted from total distance of 27 meters. As shown in the table below, we can see that the packets are being set for service. Next, the service conducted with good network quality at the closest distance indoors. From the result of chat and GPS function are similar to indoor and outdoor. So we were able to conclude that the network performance is sufficient. In this case of video, as the network performance deteriorated, the quality of video was lowered. So it was possible to confirm that fewer packets were sent or received. And conclusion. In this study, a system was developed to enable information transfer in disaster area by building a communication network using drones and developed in our own web service. A thorough field experiment conducted in an environment similar to the disaster area, a communication network ability that can recreate a signal similar to a general Wi-Fi environment was confirmed under both TCP and UDP conditions. In addition, applications were able to be used smoothly through the established network. The system developed through this study will be able to reduce the confusion caused by the lack of communication. Through future result, multiple drones are connected to expand the communication area. Additionally, the established intranet is connected to the intranet, such as satellite communication. Then the difficulty caused by lack of communication in the disaster area can be solved. And thank you for listening.
네, 고맙습니다. 네. 진행하면서 뭐 힘든 일도 많았을 것 같은데, 네. 잘 좋은 결과 만들어줘서 네, 고맙습니다. 그리고 지금 사실 예정된 시간보다 조금 지나긴 했는데, 우리 지금 사실은 이제 처음 지금 1시부터 아마 수업인 학생들도 좀 있고 해서 이제 좀 몇 명이 좀 나가긴 했어요. 근데 아마 그래도 여기 있는 학생들 중에 우리 선배들한테 궁금한 것도 있고, 특히 이제 올해 그 글로벌 인재 프로그램을 참여하고 싶은 학생들도 혹시 있을 것 같은데, 뭐 선배들한테 뭐 궁금한 게 있으면 자유롭게 질문해 주셔도 되고요. 네, 조금 마지막에 발표해 주신 그 강시원 학생 팀의 그 사진 보면 진짜 아주 정확하게 아주 날씨가 막 표현이 돼 있더라고요. 그죠? 막 눈도 막 밖에 보이고 막 그 추운데 떨고 있는 얼굴들도 막 보이고 하던데, 네, 혹시 뭐 궁금한 거 있으시면 네, 한번 질문해 주세요. 네, 자유롭게 마이크 켜고 질문하셔도 되고, 쑥스러우면 네, 채팅방에 쓰셔도 되는데 네, 괜찮을 것 같아요. 그냥 말로 해주셔요. 네. 올해는 사실은 그러니까 지금 이제 다른 교수님도 이제 포인트 지적해 주셨는데, 그 저희 여러분 선배들이 진행했던 것보다 좀 더 다양한 프로젝트가 진행이 됐어요. 그러니까 그 처음에 퍼듀에서 그러니까 제시해 준 그 프로젝트 프로포절도 사실 거의 2배 정도였거든요. 그 전에 한 10개 정도, 뭐 한 12개 정도였다면 올해는 19개, 뭐 20개 이 정도가 이제 프로포즈가 됐기 때문에 아마 여러분들이 선택할 수 있는 그 선택의 폭도 좀 더 넓었던 것 같아요. 네, 그래서 지금 생각보다 되게 다양한 분야에서 발표가 됐다고 네, 네, 교수께서 칭찬해 주시네요. 네. 혹시 뭐 지금 교수님들 중에 혹시 여러분들 중에도 마찬가지이긴 한데 지금 이제 했던 그 프로젝트를 조금 더 아마 이제 졸업 프로젝트는 이미 이제 시작이 해서 좀 어려울 것 같고 다른 후배들이 조금 더 이어서 해줬으면 좋겠다 뭐 이런 걸 또 있으면 뭐 제가 먼저 제안을 해주셔도 되고 아마 여기 그 다른 교수님들이랑 같이 좀 보고 조금 더 후배들이 좀 더 이어서 좀 더 이렇게 더 퓨처워크를 좀 더 이렇게 디벨롭해 나가면 좋겠다는 그런 부분도 있으면 아마 좀 제안을 할 수도 있을 것 같아요. 네, 근데 이미 이제 프로젝트를 진행해 본 학생들이 의견을 주는 게 좀 더 좋을 것 같으니까, 네, 진행하시면서 이런 부분은 좀 아쉬워서 좀 더 했으면 좋았을 텐데 우리가 시간이 안 돼서 다 못했어요라든가 우리가 이걸 다 더 진전을 못 시킬 것 같아요. 이런 부분들이 있으면 네, 자유롭게 의견을 주시면 좋을 것 같아요. 네, 지금 학생들이 뭐 그렇게 막 질문을 많이 하지 않네요. 한번 누구한테 이렇게 물어볼까요? 너무 그런가? 네. 다른 교수님들도 네, 오셨는데 네, 한 말씀씩 해주시고 그러면 저희 시간이 좀 지났기 때문에 네, 프로그램 오늘 뭐 이건 좀 종료하는 거로 하려고 하는데 잠깐만 네. 고용준 교수님이 눈에 보입니다. 네, 고용준 교수님 혹시 네, 한 말씀 해주실 거 있으시면 좋겠는데.
네네네. 제가 시작할 때 없어가지고 인사를 드리는데 잘 학생들 발표하는 거 잘 들었습니다. 이게 사실은 이게 2달 동안 기간이 사실 길지는 않거든요. 임성 교수님께서 말씀하신 대로 길지 않고 또 일각의 시선에서 이게 놀러 가는 거 아니냐라고 바라보는 시선도 많이 수 있는데 한 거 보고 결과물을 보면은 그 짧은 시간 안에 뭐 많이들 하신 것 같아요. 협력도 외국인 친구들이랑 협력도 잘하고 그리고 발표도 다들 영어 잘하는 학생도 많고 저보다 잘하는 것 같은 학생도 많이 보이고 프레젠테이션 전반적인 이 발표의 흐름도 논리적으로 잘 진행이 된 것 같습니다. 전반적으로 다 잘 들었고 그리고 여기 학생들 몇몇 제가 1학년 때 같이 미국 갔다 학생들도 있거든요. 그 학생들 또 이번에도 잘 선정돼서 다녀온 거 보니까 또 반갑기도 하고 이러네요. 네, 이건 좀 개인적인 의견이었고 네, 어쨌든 모두 수고 많으셨습니다. 잘 들었습니다.
네, 혹시 네 감사합니다. 아마 네 지금 말씀하신 것처럼 아마 1학년 때 아마 그 실리콘밸리 투어를 갔다 온 학생들도 이번에 이제 포함이 돼 있었는데 네, 좋은 경험이었을 것 같아요. 혹시 다른 지금 교수님들도 계신데 다른 교수님도 혹시 말씀해 주실 수 있을까요? 네. 아니면 자유롭게 우리 포드에 갔다 왔던 우리 학생들도 좀 동원이가 딱 눈에 보니까 이동원 학생이 한마디 해줄까요? 뭐 좀 어려웠던 점이나 여기 지금 후배들도 있고 하니까 어떤 점이 좀 학생들한테 지금 앞으로 준비하는 학생들한테 좀 해줄 말 있을까? 선배로서?
네. 17학번 이동원입니다. 일단은 생각보다 상당히 알차게 프로젝트를 진행한 부분에 대해서는 상당히 만족을 하고요. 근데 저희는 이제 코로나 상황 때문에 격리당하는 친구들도 좀 있었고 좀 아픈 친구들도 있었는데 다음번에는 좀 그런 게 많이 완화돼서 좀 더 다양한 활동이나 여행 같은 거를 좀 즐겼으면 좋겠습니다. 프로젝트 관련해서는 다 충남대학교 학생들은 잘할 거라고 믿기 때문에 좀 다양한 경험을 좀 많이 쌓고 오셨으면 좋겠습니다.
네, 고맙습니다. 네, 또 예성도 한마디 좀 해볼래요? 네. 근데 지금 잠깐.
들어와서
네, 이거 질문에 대답을
질문에 대한 답을
해주면
하는
좋을까?
게
네, 그러면 좋을 것 같아요. 지금 네. 좋은 아이디어.
영어로 소통하는 게 쉽지는 않을 거예요. 왜냐하면 그냥 일반적인 회화를 하는 게 아니라 기술적인 얘기를 해야 되기 때문에 그런 부분이 쉽지는 않을 수 있는데 반대로 생각해서 또 그런 용어만 알게 되면 그 다음부터는 또 소통이 어떻게든 되거든요. 그래서 그런 부분은 크게 어렵지 않고 오히려 이제 퍼듀 학생들이랑 친해지고 나면 퍼듀 학생들이 이런저런 이제 퍼듀에 대한 좀 재밌는 뭐 정보나 이제 근처에서 좀 재밌게 놀 만한 부분들 좀 많이 알려줘서
되게 친해질 수 있는 되게 좋은 기회 됐던 것 같아요. 그래서 소통하는 게 좀 힘들긴 했지만 좋은 기회였다 라고 생각됩니다.
개인적으로는 뭐 특별히 더 좋았던 뭐 재밌었던 활동이 뭐가 있었을까요?
저는 퍼듀 농구 경기를 정말 즐기고 왔습니다. 농구 경기장이 학교 안에 있어서 걸어서도 왔다 갔다 할 수 있고, 근데 좀 티켓이 그때 남자 농구가 이제 너무 잘해서
네.
이번에 결국 결승까지 갔더라고요. 토너먼트
네.
결승까지 갈 정도 실력이어서 다 솔드아웃이 돼가지고 그때
네.
이제 리셀로 구해서 보긴 했는데 그래도 정말 재미있는 경험이었어요. 그래서 꼭 퍼듀 가신다면 퍼듀의 그 경기를 꼭 보시는 걸 추천드립니다.
네, 고맙습니다. 지금 우리 그 이혜성 선배가 얘기한 것처럼 그 매년 여러분 선배들은 다 그 농구 경기 관람을 했어요. 근데 그 퍼듀가 있는 지역이 다른 그런 막 재미있는 익사이팅한 그런 스포츠가 막 유행하는 그런 곳이 아니다 보니까 그 전 주변에 있는 모든 시민들이 그 대학 농구에 다들 몰입을 해요. 그래서 인기가 되게 많아. 잘하건 못하건. 그런데 올해는 특히 잘했어요. 뭐 항상 계속 탑5에 있다가 마지막 지금 예상 말대로 지금 결승전까지 갔다고 하니 얼마나 지금 티켓이 불티 났겠어요. 그래서 아마 그 현지에 계신 교수님이 여러분들 아마 여자 농구를 이렇게 보여주는 거를 하셨는데 매년 가면 이렇게 그 구경할 수 있는 기회는 있어요. 네, 그걸 좋아했군요. 혹시 뭐 박지우 학생은 뭐 또 뭐 재밌는 활동이 뭐가 있었을까요?
글쎄요. 저 개인적으로 겨울 날씨 이런 걸 좀 좋아해서 퍼듀 그쪽 대학이 눈도 엄청 많이 와서 저는 그 윈터 스톰 그런 걸 처음 겪어봤거든요. 그래서 한국에서는 좀 겪지 못하는 날씨가 뭐 재난 상황이긴 하지만 전 좀 나름 재밌게 다가왔던 것 같습니다.
네, 그것도 참 특이한 경험이죠. 네. 그리고 제가 사실은 여기 우리 컴퓨터 융합학부에 지금 새로 오신 저희 사실 다시 또 정확히 말씀드리면 또 소프트웨어 중심대학교 사업단의 전공교부 부장교수님이신데 김정욱 교수님을 소개시켜 드려야 되는데 제가 놓쳤어요. 네, 지금 여기 계시니까 교수님 소개시켜 드리면서 교수님께 한 말씀 좀 들으면 어떨까 싶은데요. 네.
예, 안녕하세요. 저 이번에 인공지능학과에 새로 들어오게 된 김종익이라고 합니다. 여러분들 뵙게 돼가지고 반갑고요. 여러분들 발표를 들어보니까 짧은 시간 안에 굉장히 다양한 것들을 아주 잘 하셨더라고요. 특히 인상 깊었던 건 보통 연구하는 사람들이 어떤 절차를 거쳐가지고 연구를 수행하고 리포팅을 하거든요. 근데 그런 종류의 절차들을 굉장히 잘 익히신 것 같아가지고 짧은 시간 안에 학생들이 굉장히 많이 성장할 수 있구나 이런 것도 알게 됐고요. 그리고 학생들 뭐 잘한 학생들도 있는데 조금 전반적으로 아쉬웠던 건 원래 교수라는 분들은 다 아쉬운 걸 지적하는 사람들이라 좀 아쉬웠던 건 비교 연구가 조금 적었던 게 아쉬웠던 것 같아요. 기존에